Let's jump right in. Welcome to this explainer. Today, we're diving into the incredibly complex, overlapping biological systems of the female reproductive tract. But don't worry, we aren't just going to stare at dry anatomical charts today. Instead, we're going to look at this entire physiological process as what it truly is, a beautifully orchestrated, lifelong symphony. Think of it like this. Every hormone is a note, every organ is an instrument, and when they all play together, they create the absolute rhythm of human reproduction. It is honestly fascinating. So here's our game plan for today. We'll kick things off with a lifelong reproductive journey, move on to the brain's command signals, zoom in on the ovarian cycle cells, check out the systems of the uterus, tubes, and cervix, and wrap up with how to actually track your body signs.
All right, part one, the lifelong reproductive journey. Let's zoom out and look at the big picture.
When you look at a person's entire lifetime, the secretion of gonadotropins changes drastically. It's not static at all. During childhood, the hypothalamus is basically quiet, producing virtually no signals. But then, as puberty hits, it's like a switch flips. Upstream signals in the brain wake up, triggering this gradual increase in hormones. This ushers in the active adult reproductive period, the phase characterized by those dramatic cyclical peaks and valleys. And eventually, things settle down again as the body transitions into senescence or menopause. Moving to part two, signals, and specifically the brain's commands. Because really, nothing happens down below without the brain lifting its baton first. To really read the sheet music of this symphony, we have to understand the brain's chemical text messages. The star of the show here is a hormone called GnRH, coming right from the hypothalamus. And here is the truly fascinating part. GnRH doesn't just flow constantly. No, it has to be pulsatile. It gets delivered in these rhythmic, perfectly timed bursts. Those pulses travel down to the anterior pituitary gland, which then acts on that signal to release our primary heavy hitters, the gonadotropins, luteinizing hormone, or LH, and follicle-stimulating hormone, or FSH. Now, this whole setup is known as the HPG axis, or the hypothalamic pituitary gonadal axis. It's basically the chain of command. The master control center up in the brain sends those LH and FSH signals cruising down the bloodstream straight to the gonads, the ovaries. And in response, the ovaries get to work producing the sex hormones we hear about all the time, estradiol and progesterone. Okay, so how does this system keep from spiraling out of control? For most of the cycle, the body relies on a negative feedback loop. Basically, when progesterone and low levels of estrogen are floating around, they politely tell the brain, hey, we're good down here, dial back on the LH and FSH. But right at mid-cycle, that completely flips. Boom, positive feedback. High sustained estrogen from a growing follicle suddenly tells the brain, wait, more estrogen means I need way more LH. And that sudden shift causes a massive mid-cycle LH surge. And that surge is exactly what forces ovulation. Let's head into part three, cells, focusing on the ovarian cycle. Because those brain signals, they're about to hit their target. Let's walk through the actual lifespan of a follicle. Under the influence of FSH, a tiny primordial follicle starts to grow and mature into what's called a Graafian follicle, which is just packed with fluid and estrogen. Now, remember that massive LH surge we just talked about? When that hits, the follicle literally ruptures. That is ovulation, the release of the oocyte or egg. But the coolest part is that the leftover shell of that ruptured follicle doesn't just die off. No, it gets repurposed. It transforms into the corpus luteum, this specialized yellow body that becomes an absolute factory for pumping out progesterone. And this is where you see the magic of the whole system. The brain signals perfectly synchronize two entirely different organs at the exact same time. Up top, in the ovaries, you've got the follicle growing and becoming the corpus luteum. Down below, in the uterus, the estrogen from that growing follicle is busy rebuilding the uterine lining. Then, the progesterone from the new corpus luteum steps in to make that lining rich, secretory, and perfectly prepped for a fertilized egg. It's a total package deal. But what happens if an egg isn't fertilized? Well, the corpus luteum has a very strict built-in expiration date. It only lasts for exactly 14 days. Once the clock runs out, the structure literally collapses, its cells degenerate, and the progesterone factory shuts down. That sudden, steep drop in hormones is the exact trigger for menstruation. The old corpus luteum is then replaced by a little collagen-rich scar on the ovary called the corpus albicans. All right, moving into part four, systems. Let's look closely at the instruments themselves, the uterus, tubes, and cervix. When you map out the systemic changes happening all at once, it's honestly mind-blowing. During the proliferative phase, which is driven by estrogen, the inner lining of the uterus, the stratum functionalis, regenerates, growing by about 2 to 3 millimeters. But at the exact same time, the cervix is responding by ramping up its mucus production by 30-fold. I mean, that's huge. Then, as we move into the secretory phase, driven by progesterone, that uterine lining thickens even more, up to 5 to 7 millimeters, and becomes highly vascular to prep for potential pregnancy. And we can't forget the fallopian tubes, where there's this incredible cellular dance happening. The lining here is not static at all. Mid-cycle, when estrogen peaks, the ciliated cells actually grow taller. They physically increase in height so their little hair-like structures can actively sweep the ovulated egg down toward the uterus. Meanwhile, their neighbors, the non-ciliated PEG cells, start releasing vital lipids and glycogen. This basically lubricates the pathway and preps incoming sperm, giving them the necessary energy boost to go fertilize the egg.
Which brings us to our final section, Part 5, Tracking Your Body's Signs. How do all these microscopic cells and invisible signals actually show up in real life?
The truth is, you can actually track the effects of these shifting hormones by looking for some very specific physical clues. For instance, right around ovulation, as progesterone kicks in, you might notice a slight bump in your basal body temperature, usually about 0.5 degree to 1 full degree. Other systemic ripples from these hormone surges can include tender breasts, abdominal bloating, and sometimes even a slight sharp ache on one side of your abdomen exactly when that Graafian follicle ruptures. But one of the absolute most obvious external signs is a change in cervical mucus. Thanks to that massive spike in estrogen during the late follicular phase, so right before ovulation, the mucus tangibly transforms. It goes from being kind of scant and thick to becoming clear, incredibly copious, and super elastic. People often compare it to raw egg white. And this isn't random. That specific slippery texture literally creates a supportive biological highway, helping sperm survive and swim up into the uterus. And you know what? Modern ovulation prediction kits use this exact science. Rather than just guessing based on symptoms, these kits measure urinary metabolites. By detecting things like E3G, which is just a breakdown product of estrogen, and catching that crucial LH surge we talked about earlier, these tests can accurately map out your 6-day fertile window. It just goes to show how incredibly predictable and methodical our biological conductor really is. So, we've connected the whole circuit today, from a tiny rhythmic pulse deep in the brain to sweeping physical changes across the body. It really drives home the fact that a menstrual cycle is never just a period. It is an ongoing, beautifully coordinated masterclass in systemic synchronization. So I'll leave you with this. Now that you know the sheet music to this lifelong symphony, how will you listen differently to the subtle cues your body plays every single day?